What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button, and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
We were prompted to talk about this topic by the stories of two colleagues who actually faced with ineffective starting wires. One received the wires as an inheritance from the previous owner, buying a used car, and the other bought his own in the supermarket, choosing far from the cheapest. However, several cases of use, when the engine of the car with a dead battery stubbornly did not want to start, only sobbing and crackling. Retracting relay starter led both to the idea that something clearly goes wrong. Careful inspection revealed the cause, in view of which we decided to tell our readers about the nuances of making such a seemingly simple thing as two thick wires with crocodiles on the ends. All the more so that with the onset of cold weather many people go to car stores for this accessory, and the demand for them rises sharply. Anyone who remembers school physics and is able to fix an outlet at home knows that the thicker the wire, the more current it can carry through it. Yes, a large current can flow through a thin wire, but not for long. The voltage drop on the wire will be too great, and thermal heating will quickly melt first the insulation, and then the metal itself conductor. For this reason, the wires for cigarette lighter have the same, plus or minus, cross-section as the regular starter wires in the car. The table of conformity of cross-section and operating currents has seen, probably, everyone who is familiar with electrical engineering at the household level. If you take from their values close to the starter power, you can see that 200 amperes of current requires a wire cross-section of about 70 square millimeters. 250 amps requires a wire cross-section of about 90 square millimeters. 300 amperes requires a wire cross-section of about 120 square millimeters. Flexible wires consist of individual cores, which have the shape of a cylinder, and the total cross-section is determined by calculating the cross-section of an individual wire by measuring its diameter and calculating it according to the well-known formula S equals R2, after which the result is multiplied by the number of cores. In principle, you can simplify the process without much harm to accuracy and calculate the cross-section by measuring the diameter of the whole package of wires at once. For our purposes, this is quite sufficient. The problem is that few car owners pay attention to this parameter, especially since manufacturers of cigarette lighter wires do not advertise it. The buyer looks at the cross-section of the wire indirectly, relying on its external thickness by the diameter of the insulation, and separately assesses its flexibility, because he knows how plastic tends to blister in cold conditions, and even more so in frost. Sometimes the insulation of wires in the frost becomes so rigid that they cannot even be stretched from car to car. As soon as the wires are released from the hands, they tend to shrink back into the ring in which they were twisted during storage, tearing off the crocodiles from the battery terminals. As a result, if the wire is visually thick and elastic, it is considered suitable and bought. However, the trouble is that only the plastic braid can be thick, and inside it sometimes hides natural Chinese greed. This was the case with one of our colleagues, who, having learned the reason for the failure, gave the wires to us for experiments, allowing us to simply dispose of them after the research. The outer diameter of the wire by insulation was 7.5 to 8 millimeters. Not too thick, but generally tolerable. In fact, almost the entire array was filled with smelly plastic, in the thickness of which was hidden a thin bundle of copper with a total diameter that did not even reach 2 millimeters. Thinner than a matchstick. Recalculation of the cross-section gave us an operating current of about 20 amperes, although in fact, in a good way, starting wires should withstand at least 200 amperes. This is the reason why these wires were simply unable to work. The voltage drop on them was so great that the current from the donor battery simply did not reach the recipient battery in the proper amount. But if in the first case the wires were not only cheap in essence, but also looked the same, then in the second case they looked very high quality. Powerful crocodiles in plastic trim, thick cables in colored sheaths that kept their elasticity very well in a cold, a good thing, at first glance. However, they still worked lousy, and several users with varying success deprived the owner of faith in their reliability. The reason for the failures was also easily found. Firstly, despite the high quality and thick insulation, the copper conductors inside do not stand up to criticism. They are again as thick as a matchstick, or not much thicker. And secondly, these wires use an extremely unsuccessful method of terminating the conductors in the terminals of crocodiles. A bundle of copper conductors is not crimped in the metal directly, rigidly, but wrapped on the insulation and crimped together with it. As a result, the contact is not rigid, but through a layer of rubber plastic, which over time loses elasticity and the pressure of the wire to the metal terminal weakens. In order not to make a mistake when buying starting wires, we will give some important recommendations. The first, as is already clear, concerns the working cross-section of the wire and its ability to transmit high currents without sagging or overheating. Before purchasing, you should look at the place where the cable is terminated. There you will see a bare section, which will allow you to assess its cross-section. Technically measure the thickness with a caliper and calculate 2 pi r² is unlikely to be possible. There, as a rule, with a measuring tool cannot fit. But you can use an ordinary match as an approximate standard. Its thickness is about 2 mm, respectively. The cross-sectional area is 4 square millimeters. Copper wire of this cross-section is designed for a current of about 30 amperes, so that the total cross-section of the starting wire should exceed the thickness of the match at least 3 times, and in a good way, at least 5 to 6 times. If the bundle of copper strands is comparable to a match, such wires should not be taken even for free. They can only be used to reliably start a moped. The second tip is about the quality of the wire termination into the metal of the alligator. Avoid the aforementioned shoddy clamping through the plastic of the insulator. Pressing should be rigid, without intermediaries. Or, as an alternative and equivalent option, soldering. The method of cable termination is determined simultaneously with the study of its cross-section. To do this, you need to pull off the crocodile rubber insulating cover or completely unclamp its jaws. By the way, manufacturers of high-quality wires connect the upper and lower jaws of each crocodile with a piece of wire of smaller thickness in order to increase the area of contact with the battery terminal and reduce current losses. This is not mandatory, but it is highly desirable. The third tip concerns the material of the jaws of the crocodiles. In cheap versions, they are either bare steel, or the steel is electroplated with a thin layer of copper. Both of these options are bad and can be easily detected with a magnet. The steel introduces additional resistance, which is amplified by rust, and the thin layer of copper quickly wears off. The correct option is pure copper. It is either used to make the whole crocodile, or, which is quite acceptable and not the least bit worse, only the contact part of it, the toothy one. In conclusion, using cigarette lighter wires to start an engine is not only impractical but also potentially dangerous. The wrong material and insufficient thickness of these wires can lead to overheating, damage, or even fire hazards. Understanding the limitations of these components is crucial for safe and effective vehicle operation. Always rely on the appropriate equipment designed for starting engines to ensure reliability and safety. Thank you for watching, and stay informed about the best practices for your vehicle's maintenance.